Welcome to Lesson 5, where you stop reading unit files and start writing them. We're going to take a real Python Flask app, launch the old-fashioned way with a bash script, and promote it, one trait at a time, into a proper system service. 4 pieces: the bash version that mostly works, a minimal 5-line .service, a production-grade unit with user, restart, and hardening, and finally a debug playbook for when it stubbornly refuses to start. So here's our starting point. A tiny Flask app at opt myapp server PI, launched either with a backgrounded Python 3 or, if someone's feeling fancy, no hup with output redirected to a log file. And honestly, it works on Tuesdays. But count the failure modes: reboot kills it, a crash leaves it dead, logs land in some random file with no rotation, it runs as whoever started it, usually root, and there's no standard way to ask, is it up? Every single one of those panes maps directly to a systemed feature we're about to add. So here's the whole journey on one screen. The same Python app in 3 columns, each one adding traits to the last. The middle column is the smallest unit file that actually qualifies as a systemed service. A unit block, a service block, an install block, done. The right column is what you'd actually ship. Same skeleton, plus a dedicated user, a working directory, restart on failure, and proper network ordering. Most engineers stop at the middle. Senior engineers push to the right, and over the next few slides, we'll walk that path one trait at a time. Step 1 is the minimum viable service, and it really is just 5 non-comment lines. A unit block with a description and an ordering hint, a service block pointing at your Python binary, and an install block telling system to start it at boot. Drop that file in, etc. system, run daemon reload, enable. Now, and you've already got auto start, log capture into journaled, a working restart command, and a standard status interface, none of which your no-hup script ever gave you. Now we promote that same unit to production grade, same app, same ExecStart, but every other line earns its place. We pair after with wants on networkonline.target, so we both wait for and trigger the network. We drop privileges with user and group, pin the working directory, and load secrets from an environment file instead of hard-coding them. Restart on failure with a 5-second backoff handles crashes, journal capture is explicit, and protect system and no new privileges are your first taste of sandboxing. Every one of these lines exists because somebody somewhere got paged at 3 a.m. With the unit file written, day 2 operations begin. First deploy is the ritual. Create the system user, copy the unit into etc. system, daemon reload so system sees it, then enable, now to both start it and wire it for boot. To change the unit itself, prefer systemctl edit. That creates a drop-in override instead of mutating the vendor file, then daemon reload and restart. Updating just the binary is simpler. Copy in the new code, restart. And the one rule that saves you at 3 a.m. Always keep the previous binary as a dot back, so rollback is 1 CP and 1 restart away. And eventually, usually at the worst possible moment, it just won't start. So here's the 4-step playbook, in order. Step 1. Actually read systemctl status. The exit code alone often names your bug. 203 means the binary isn't where you said it was. 217 means the user doesn't exist. Step 2, journalctl umyapp n50 for the full story, including any stack traces your app printed on the way down. Step 3, systemd analyze verify catches the typos that daemon reload silently swallows. And step 4, the tiebreaker. Run the exact ExecStart command by hand as the service user. If it works manually but not under systemed, you've narrowed it to environment, path, working directory, env vars. By step 4, you'll have your answer 95% of the time. Now zoom out with me, because that debug playbook only makes sense inside a bigger mindset shift. The instinct, when you're new, is to grab a 30-line template off the internet and paste it in. The senior move is the opposite. Start with 5 lines and add each directive only when you can name the question it answers. User equals my app answers who runs this. Restart equals on failure answers what if it crashes. If you can't articulate the question, you're cargo culting, and you'll have no idea what to do when it breaks. Expect 3 or 4 iterations. That's not failure, that's the job. So here's that mindset, distilled into 10 steps you can actually run. Notice the shape of it. You prove the binary works before you ever touch a unit file, you validate before you reload, and you don't trust enable until you've survived an actual reboot. Each row has a success looks like column, because that's the honest checkpoint. If you don't see active running or created symlink, you stop and debug right there, not 3 steps later. Print it for your first service. By the 5th, you won't need it. Reading is one thing. Muscle memory is another. So here are 3 drills, 90 minutes total, that walk you through the full arc. First, author a tiny Hello World service end-to-end in 20 minutes. Feel the life cycle. Then promote it. Add a dedicated user, protect system, no new privileges, restart on failure, and watch the resilience traits actually catch a failure you cause yourself. Finally, break it on purpose. Bad ExecStart, bad user, bad working directory, and walk the debug playbook until each failure signature is something you recognize on sight. Before you go run those drills, here are the 5 mistakes you're most likely to make. The ones that eat 30 minutes each until you've seen them once. Running as root because you forgot user. Forgetting working directory and watching openconfig.yml fail. Putting shell redirection in ExecStart, which system doesn't parse, print to stdout, and let journaled handle it. Skipping restart, so a crashed service just stays dead, and waiting on network.target when you actually need networkonline.target with a matching wants. Memorize the fix column. You'll save yourself hours. And that's lesson 05. You took a Python app from a fragile bash launcher, promoted it to a minimal service, hardened it into something production grade, learned the deploy lifecycle, and now have a debug playbook for when things go sideways. Next up, lesson 06. Journal CTL and logging. Because once you're operating services, you need to actually see what they're doing. Structured queries, persistent logs, rotation. From grep and awk to one-liners that just answer the question. See you there.